Okay, we are watching the slide mode.
All right. Okay.
Okay, so now it's a presentation mode. So can you try to pass one slide so to check it works?
I can go past it, right? You can see this the slide name.
Okay. So that's the first one is ready, and then for the second presentation, it's Frank Hoffner.
Yes.
So can you stop sharing? So we can test the second one.
Yeah, well, I can try, but actually, I thought you might want to play the recording. Wouldn't that be possible? Because otherwise it's tough to meet the 10-minute time constraint.
Okay, I think I can, yeah, or if you want to play the recording by yourself, maybe it's, or if not, I can just play the one.
Yes, that would be nice if you could play the recording. I am there for answering questions, but I still can share my screen, but meeting the time schedule in 10 minutes time, it's tough.
Okay, but then, so it's just, you have the video there, maybe it's, I think it's better to play it, but it's okay with me to do that. Okay.
Well, can you play the video? Or do you want me to play it?
Yeah, I think it's better that if you play the video, if you want to play the video, I think it's better that you play it when it's your turn.
Okay.
So I think we are ready to start. I think it's already been recording, right, Sharon?
Yes.
Okay. So I think we have done all the setup for the session. We didn't have the time to do it before because the opening was in this room. So welcome everybody to the session A1 about computer science education, and we have two papers about data mining solutions to support programming courses. So I think we can start with the first one, which is automatically classifying student help requests and multi-year analysis. So Hsiao, the floor is yours.
All right, shall I start? Hello everyone. My name is Hsiao. I'm from NC State University. Today I'm going to talk about our research on automatically classifying student help requests based on a multi-year analysis. Over the last decade, we all have witnessed a significant increase in the interest of computer science and the enrollment of computer science courses. This increment has brought a lot of pressure for the instructor to address the substantial demand of student help requests, which include using office hours to interact with a single student. Therefore, boosting the efficiency of such activity can greatly relieve such pressure and make sure more students can get help they need in time. For this research, we focus on 4 research questions listed here. For question 1, we plan to develop the categorization of students' questions in office hours based on how they describe it. For question 2, we build an automated classifier using machine learning techniques and prove the robustness of our model over different semesters to address research question 3. Finally, analyze the difference of online office hours and regular face-to-face office hours to address question 4. Many prior research have categorized student help requests in multiple systems like MOOC discussion forum topic categorization or Piazza post categorization. But research on categorized office hours questions has never been discussed. For office hours, we also find some research about potential problem and solution about it. One claims that incorporating diverse teaching techniques like peer programming could reduce the wait time of office hours. Some researchers set up an experiment about virtual office hours, and they found that it's actually less efficient. Another research observed some students avoid seeking help when they actually need it and analyze the factors behind it, such as the cost of going to office hours and personal characteristics. To address our research questions, we collected our data set of 7 offerings of Java programming concept or CSC 216 class offered at NC State, starting from fall 2017 to fall 2020. This course has a heavy load on Java programming project and a huge enrollment each semester. Usually students in NC State take this course in their second year after they already complete the first Java programming introductory course. In fall 2020, this course has moved fully online due to the pandemic. We collected office hours request data of this course from a ticketing system called My Digital Hand or MDH. Students using MDH request help during office hours by creating a ticket. The figure on the right side show you like what a ticket looks like. You can see that it has 4 fields, and they all need student to type in test to create it. Once the ticket is created, it is visible to the teaching staff who can then use it to prioritize the interaction queue. And in our research, the data we gathered from the MDH include the participants' information, the time and duration, and on the context of each office hour interaction. Among the 4 fields, like on the right side here, we focus on classifying the my problem is field, which actually is just a description of the problem. So let's first take a look at what question actually students ask. Here are some example questions, description from our data site. Clearly, most questions are about debugging errors or unit testing. Also, what is interesting is how students describe their problems. In the first 4 questions, they don't actually tell you what specific error they encountered, and the 5th question don't even tell you like what type of help is needed. We also have this JUnit test question here, which is clearly a copy and paste from the console. The last question is the only one described in 4 sentences and can be fully understood by the teacher staff. Based on the observation we made and the idea provided by the teaching staff, we divided those questions into the following 5 categories. The first category is called useless, which means the student did not provide any information at all. The teaching staff cannot get anything from this type of question, and it definitely needs further communication to understand what exactly does the student need help with. Insufficient categories are the questions that only provide limited information. The teaching staff can vaguely get some idea what the question is about, but still need some more clarification during the start of the interaction. And on the contrary, sufficient questions describe the problem with abundant information. Teaching staff can quickly understand a student's question, and it is possible that they already have a possible solution before the interaction even started. The next category is called copied error. Some teaching staff claims that they saw students like to do this, like copy and paste their error message directly from the console. And the teaching staff could potentially saw similar errors before and just quickly responded. And the final category is about test cases failures. Some teaching staff are actually more familiar with those test cases, and assigning this type of question to them is more effective. With this categorization, one of our researchers manually labeled all the data. Then to make sure our labeling is accurate, we randomly generated a subset of 150 unique questions and send it to another researcher to rate. In this subset, we reviewed the label of 10 questions for each category as example data, and the reader classifies the remaining questions. Then we compare the result with the original label and calculate the coherence kappa value. The final coherence kappa value is 0.815, which proves that our labeling is actually pretty good, is acceptable. And I'm sorry. And here are the results of our categorization labeling. On the left side, the table actually containing the distribution of all the questions of all the questions in our data set. You can see that the sufficient is the most popular one. It has 69%, and then it's the test categories with 15%, and sufficient with 12, useless with 3. And finally, surprisingly, despite of what the teaching staff told us, the least common type of question is copied error. Only 0.1% of the questions shows such behavior. So on the figure on the right side, you can see that those relationships actually remain the same for every single semester. To address research question 2, we first developed the feature for the classifier. There are 2 types of features we selected. The first type is the text meta features, which include the length, number of stop words, punctuation, and the character cases of the description. Then we plan to use the TF-IDF matrix and basic word counting matrix as features. However, the original features are too sparse, and the performance of the resulting classifier is very poor. Therefore, we compress them so that it can be compatible with the dense feature approaches. Specifically, we built a naive Bayes model based on the original sparse features and then use the predictions of it as the features. With the features extracted from our dataset, we use the light GBM, which is a type of grading boost decision trees algorithm developed by Microsoft to train our automated classification model. The training site containing all the data from the first 6 semesters, and the testing sites just for 2020 data. The reason we chose the light GBM as our modeling method is that the excellent accuracy it presents in our preliminary research and a relatively good speed. Before we start training, there's still one more problem. As shown in the result of research question 1, the categories are highly imbalanced. Therefore, we applied a small technique to our training data set, which randomly oversampling the minority category until they all reach the same amount of the major category. And the results are our model reach accuracy of 91.8, which is pretty good, and the precision required F measure of each category suggests that the performance of our model is quite balanced. And then to prove our model stability over semesters in question 3, we perform a leave one out cross validation on a semester by semester basis and here are the results. And clearly you can see that all the models achieve an accuracy over 90% except for fall 19. In light of those results, we believe that our modeling method is sufficiently stable to assist in processing unseen semesters. Finally, because in fall 2020, our office hours has been moved to online, so we will compare the online office hours and face-to-face office hours by comparing fall 2020 data and other semesters data pattern. In the online office hours, the workflow has also changed. After a student reads a ticket on MDH, the teaching staff will notify the student to find him in a Zoom meeting room. During the interaction, students have to share the screen if they want to present anything in the question. This table lists some statistics of each semesters. We focus on the percentage of students using office hours and average tickets per student. You can see that those 2 numbers are increasing each year if you separate the fall semester with the spring semesters. And however, the increment the increment of fall 2020 is actually bigger, and which could indicate that the online office hours lower the cost of attendance. And then more students are willing to participate. However, it could also mean that for 2020, it's just like more students actually need help. Here are the distribution of interaction time in fall 2020 and other semesters. The fall 2020 have a slightly larger interaction time than other semesters, which could indicate that the communication of online office hours might be more time consuming. And here are the distribution of the wait time as well. So you can see that fall 2020 have a significant larger wait time, which suggests that the demand of online office hours in fall 2020 has exceeded the capacity of teaching staff. So finally, here are the final conclusions of our research. In question 1, we developed our categorization and found that most of the help tickets lack sufficient detail. And in question 2, we successfully built the target automatic classifier, which reached an accuracy of 91.8%. In question 3, we proved that our model is robust across different semesters. And in research question 4, we found that online office hours are more popular and the communications are more time consuming than in person. So our major limitation is that the model we built only applied to a single course. So it may not work on other CS courses or non-CS courses. Also, our analysis of the online office hours is actually pretty shallow. We could expand this analysis and see students' precise attitude toward online office hours by more observations and gathering more other related data. And also, we think that evaluating its effectiveness of online office hours could also be very interesting. In the future, we plan on apply our method to other courses and investigate other aspects of the online office hours. We can analyze the similarity of the questions in the same office hour session, or potentially build an interaction time prediction model. We also could apply our model on MDH to provide automated scaffolding, which can assist students to better describe their problems. And for example, if a student describes their question as this catalog implementations, our model can quickly identify it as insufficient and notify students to revise it. After revisement, student might write something like this, and this is much clearer. So we know that students don't know how to check if the catalog element has the name and the section. So by this, we can send it to the Q&A system, potentially send it to the Q&A system if it's actually a common confusion by the students. And we can also just guide it to other material which could contain potential answers. Our research is supported at NCF, and thanks for listening. I'll be taking any further questions.
Okay, thank you very much, Shaghayegh, and let's give you an applause virtually.
Thank you.
So, Colin, who's also shared with me in the session, let's see if there is some questions reported in SpeakUp.
Well, there is one so far. So the question appears to be anonymous, but do we have a sense of what kinds of questions were more frequent in fall 2020 than in other semesters, right? So in the change of types of questions or topics relative to prior semesters, given the nature of the course then?
Well, from what I see here, like my statistic shown here is that there's not really a big difference on which topic is more popular or which category is more popular in the fall 2020 and then and other semesters. There's nothing like that yet. And it's also the basic, I think I can show you here, is that yeah, so let's see that for 2020, generally the insufficient type is just oh, hold on, I can see this. This is just above 0.7, is that like precisely according to the insufficient. So they're basically the same. The students don't actually come to office hours, and their behavior just don't change that much compared to the face-to-face office hours. That's basically it.
So there's frequency change, but not a content change. That question apparently was from Ken. So for those of you posting questions, the Speak Up interface does not actually put your name on the questions. So if you want to have your name attached to it, just type it in the question itself. Son Zheng has a question in the chat. Son, do you want to ask it yourself?
Sure. Thank you, Colin, and thank you for the presentation. That's good. So I have a question regarding the time used to resolve a question. Is the average time of resolving a question in fall 2020 semester significantly higher or lower than the time used to resolve a question in prior semesters? That would answer part of the question regarding efficiency of office hour.
Yes, so that actually shows us here, like the fortunately have slightly larger like solving time. Interaction time is just the time difference between the interaction started and interaction ended. And we observed that the fortunately have a slightly larger interaction time. And what's more interesting is that like this 0 here, like it actually represents the questions that last within 1 minute. And the reason why there's abnormally high in both 2020 and other semesters is because that sometimes the teaching staff like forget to like open the tickets when the interaction actually started. So this could cause and when they realize it, it might be something like the whole interaction is ended, and so they have to open it and quickly just like end it. And also, but in our system, we can't really tell if that actually is the real cases. So we just put in also here. But if we just discard all those questions, all the questions that would that only last within 1 minute, the 2020 interaction time is actually larger than the other semesters. The difference is more larger, I think. Yeah, so the interaction time in other semester, if we discard all the question that only lasts in 1 minute, is around 9 minutes, and in 2020 is around 11 minutes. So there is a difference here.
And John, I see you have a follow-up. So very quickly, and then there's one other question waiting. How do we interpret the 15% that were 0 time? Those were people who canceled by and large, right?
Yeah. So as I was just speaking, sometimes the teaching staff might make a mistake and forgot to open it. And yeah, for 2020, because for 2020 is much more busier, so they might be making such mistake more often.
Okay. And as a different question, again, this is on Gather, or Speak Up, so I can't see who asked it. So if the student questions submitted in the system were limited, do you think they were limited by the capacity of the platform in some way? For example, and as a follow-up, does the RQ4 conclusion suggest that online office hours need additional time or special scaffolding of any sort?
Yeah, sorry to chime in. Yeah, that is from me.
That's you? Okay, go ahead.
Yeah, so the first, I actually have two questions for you. So for your first research question, since I'm the instructor of CSA 116, it's not 216. So basically what I found here is like students may have some issues when they want to type in very long stuff into the platform. For example, if they have some programming questions, it's very hard for them to really specify what is going on within short like sentences. So is this going to be limit some sort of like limitations for your study?
I think in some way it is like the student some because I'm also used to be a teaching staff in education, and what I observed is that some students actually don't understand what is going on when their programming is having some kind of errors. So yeah, it could mean that they actually need more help and to describe the problem, and they're just really struggling with it. Another problem is about this is that like I think for 216 it's just students sometimes just when they encounter a problem, they don't really think about it and just immediately ask for help. And it's actually abuse of office hours in my opinion. So yeah, so I think if we can recognize it as insufficient or some useless, we might like help those students to better describe the problem and then help them to realize what the problem actually is.
Okay, thank you very much. I think we should stop the questions here and move to the second paper. So thank you very much, Hsiao, for the talk and for answering the questions. And please don't stop asking. I mean, we have this speak up functionality and also the gather print down and so on. So if you have more questions, please continue sharing them with the authors of the paper.
Okay, thank you.
So we have to move to the second paper. So Frank, so are you ready to play the video you said? Or
I hope so. Let me see.
He's going to present the paper, grouping source codes by solution approaches, improving feedback in programming courses.
Yeah, I had a pretty hard time in scrunching this into the 10-minute schedule. That's why I'm now sticking to this recording, and I'm there for the for answering questions afterwards. So here we go.
If there is sound, I think we or at least I'm not hearing anything.
Sorry, when you share your screen, you have to click the option and share the audio with it.
Oh, okay. So I have to share it, stop sharing and then share it again and
with sound. There is a checkbox.
Advanced. I see. I hope that we get it now. Oh, no, it's. No, it's not the full screen. Desktop share. As homework. Welcome everybody to a talk on grouping source code by solution approaches. So let us have a look at the motivation first. We have an introductory programming course in mind where students have to write many programs to improve their skills and learn new language elements. We may have live exercises as well as homework exercises, which will then be submitted to the lecturer. It is important to give instructive feedback to the submissions, ideally shortly after the submission, which is extremely difficult in the case of live exercises. Manual grading takes too much time, and feedback in terms of the number of passed unit tests is not instructive. An empty submission may pass as many tests as an almost correct partial solution. So the type of feedback that we have in mind might be a lively discussion on different ways of solving the exercise. This requires a mechanism to group the submissions along the chosen solution approaches. We may then engage the students to discuss the pros and cons of two submissions that follow different approaches. Or we can provide feedback on how common the chosen solution is, how much of the solution has already been coded, or show another student's submission that follows the same idea but passes all tests. This enables automatic feedback on the progress even if not a single unit test is passed. So the research question is, can we group source code by solution approaches? So to what extent is that different to what we have seen already? What are the challenges? Suppose the task was as follows. Write a function that returns the mean of all positive values in an array. A possible correct solution is shown here. It identifies the number n of positive entries and their sum, from which we then obtain the mean. So what might be used to group codes? A related problem is that of plagiarism detection. To such JPEG apply some transformations to the code such that typical obfuscations do not disturb the comparison. For instance, one obfuscation technique is to rename variables. Therefore, the tool replaces all variable names by a standard token. So let's see what this comparison leads us to if we compare these two codes. JPEG returns a 100% similarity, and it is correct that the codes are structurally very similar, but it seems that the author on the right code did not really get the ideas. He increments the wrong variables. He does not increment sum but elements of the array. So while similar in terms of instructions, the code computes completely different things. Semantically, the solutions are not similar, despite the 100% similarity. Okay, a second option would be to use existing code similarity measures, such as the edit distance. It calculates the minimal number of changes that has to be applied to transform one code into another. So in this example, we would have to insert a second for loop with an embedded if statement to arrive at the code on the right, which leads already to a quite high edit distance. But in fact, both solutions are semantically equivalent. Both calculate the number of positive elements and the sum of positive elements to return the mean. The only difference is that the author of the code on the right uses two loops to do this, while the author of the code on the left uses a single loop. Structurally different, but semantically equivalent. So now let us have a look at our proposal for measuring code similarity. The code on the left is transformed into a graph first. The graph has been derived from an abstract syntax tree, but whenever we access the same variable, we reuse the same node, which turns the tree into a graph. As we have seen from the plagiarism example, it is crucial to take into account where and how the variables are used, so we put a special emphasis on the variables. We have 4 variables here, a, n, sum, and I, and they have been marked by red nodes in the graph. So let's focus on the variable sum. It occurs 3 times in the code, declared, incremented, and part of a return statement. And we can represent these 3 usages of sum as paths in the graph. For instance, this blue path corresponds to the declaration. Sum is declared in the body of average. So this is why we call these paths variable usage paths, or VUP for short. We write down the paths here at the bottom to get a textual representation of the path. So now when comparing the 2 codes that we have seen before, we turn the source code into VUP sets and can then apply standard set similarity measures to compare the code. This leads to 100% similarity for these 2 codes because we do not count the number of for loops, but only compare how the variables are embedded in instructions, which is identical for both codes. So this is the core idea of the proposal, but we need a few more extensions. So the first problem is that of variable names. Renaming a variable changes the path and introduces therefore differences when comparing the VUP sets. Here we have sum, and here the variable has been named S. So the entries are different. In the first step, we simply apply the same unification as plagiarism tools do. We rename all variables to the same token. But we will do better in a minute. The second problem is that of instruction embedding. The code we have seen before exits the function quickly in case of a null array. But it could have been coded alternatively by embedding the instructions into an if statement. While semantically equivalent, this encapsulation introduces an if segment in all the paths of the embedded instructions so that many elements of the set become different. We address this in the paper by identifying those path segments that unify most VUPs and add penalty terms for each introduced path segment. Finally, let us revisit the variable renaming problem. We solve it by switching from a single VUP set to one VUP set for each variable. So the code on the left has two variables, sum and I, and therefore we have two VUP sets, and the representation of the full code is a set of VUP sets now. For the code on the right, we do the same, and now we can identify or recognize that sum and S are used in the same fashion by comparing their VUP sets. We solve this by using or solving an assignment problem, and more details can be found in the paper. Okay, let us have a brief look on results from a real exercise. We had two different but common solution approaches shown in black and blue color, a seldomly occurring third approach shown in red, and some exotic mixtures, possibly in a transition between two other approaches shown in gray, and finally a few unfinished solutions shown in cyan blue. So let us focus on the three main approaches, that is black, blue and red. For the first simple version of similarity, that is the version where we have only one VUP set for the full code with all variables renamed, we see that the larger subtrees mix up different solution approaches. Here blue and red, and here we have all three mixed together in one cluster. So the second version that takes the instruction embedding into account separates the black solutions already quite well, but the blue and the red solutions are still mixed. Only the final third version, where we assign variables from different codes according to their VUP sets, there we succeed in finding a separate cluster for the red solution approaches, and also separate quite well the black and the blue cases. Okay, to conclude, to answer the research question, yes, it seems possible to organize submissions into groups that follow different solution approaches, and in contrast to edit distance, it is reasonably robust against the lengthy and redundant code of novice programmers. The results on real data were quite promising so far, so we look forward to further experiment with this approach. Okay, that's it. Thank you for your attention.
Okay, thank you very much, Frank, for the presentation. And again, also, let's clap your presentation. And we have time for a quick question, if there is any, because we are a bit late.
There is nothing in the Speak Up forum, so I think Ken, however, just posted something in the chat.
I think if it's a quick question, we can take it, and if not, I think it's better that we follow the discussion on the Speak Up. So it's up to you, Ken.
Well, we should keep on time, I guess. But yeah, interesting talk, Frank. Thank you. You might want to look at this Kelly Rivers paper that has some similar approaches, including an approach that anonymizes variables in a kind of similar way. But your evaluation results and techniques are super interesting. Thanks.
Thanks.
Yeah, I would add to that, there's some work by Thomas Price here that might be related, since he and Kelly are using similar stuff. So.
Okay, thanks.
Okay, so I think we are done for the session. Thank you to everybody, and please remember that you can vote for these papers in the link provided. So thank you very much.
Thank you, Olga.
We are here today, and we are here today to present you the projects we started together with around the Gaia-X initiative. Thank you. And maybe you can share my screen so yes. I can share the presentation, okay? Up. Voilà.
Thank you. I introduce to you the Gaia-X project and the data space. The Gaia-X project was initiated with French and Germany to enable a secure, open, and sovereign use of data. In this way, self-determined decision can be made on how and where data is stored, processed, and used within the data infrastructure. Sorry. Our vision is to access and share data through a federated data infrastructure to ensure innovation for our future and thanks to the next generation of information technology. It's a European cooperation because Gaia-X is now an European association, and it works on transparency, secure interfaces and standards to allow the aggregation of data while driving innovation and efficiencies within a transparent environment. We want to maximize the security and to respect the right protection to guarantee citizens' privacy as a human right and respect the sovereignty of other nations. Especially with the data space education and skill, because in this organization there is several data spaces according different sectors like health, energy, or banking, and we have a data space, an organization with specialty on education and skills. We work with all the tech stakeholders and all the private and public organizations and the data space education and skill work on the safe, ethical, trustworthy European framework for education and skills data. We want that we maximize data use and data sovereignty, and it's for AI-driven new services developments. This data space, education and skills, it's a data space for all the European countries. Next. We organize the data space with new governance organization, and in this organization, we have 4 working groups. One working group whose objective is skills. Another working group who work on the data set for AI. A third working group who work on the tech impact and decision makings. And we have a working group who work on the technical recommendation according the technical recommendation of the Gaia-X working group. And we have a working group whose name is governance, because we have governance who receive all the stakeholders. Federica?
Yes. Let me move on. Okay. So basically, the reason we are here today is that we wanted to share with you the work we started, because well, it's been several months that we've been working with all the edtech companies and universities within the French ecosystem, and we really would like to carry on a European level the vision of a data space for education and skills, because we do think that this field really justify itself a specific data space. And the main idea behind this vision is that we think it can a data space and even on a European level for this sector. So when I say education and skills, it's not only within school systems, so it can be extracurricular activities and, well, lifelong learning. And under this perspective, you can, well, we do think that there can be a data space could benefit, well, mainly the whole educational community. So we have grouped different targets on this slide, but I think you can easily understand because there could be a big interest for students, of course, in terms of personalized learning experience and tailor-made counseling services, just to give very, very brief, very, very short ideas. But of course, there is a huge interest for teachers as well. And probably, and we hope, for researchers such as all of you are, to provide data for researchers and to finally a better understanding of all the mechanism behind teaching and learning. And we do think that the politics and decision maker could also benefit from bigger amount of data, which could allow the decision making on evidence-based models. And all the companies we have gathered as well, they do find a lot of interest, because they will need data to better assess the impact of their solution, just to have also a better idea how their solution can respond to user needs, and maybe have the basis for developing new AI services. So as Claudia was saying to you before, we started to organize ourselves in different working groups, and the 4 groups you talked about, well, you can kind of find around these use cases, because we've written a position paper to present this vision to the Gaia-X initiative, and to start talking to European partners as well. So of course, behind our targets, there's the idea in the data space should offer the possibility to aggregate data sets, quality data sets. And I think most of us are in this need, and we have discussed several possibilities, like developing voice assistants, because a lot of us had a lot of us were working on voice data sets, and we were all finding the same problems to work on data sets, on useful data sets. And we were working also on the idea of skills, and just how people can use their skills, and then they can share them, and they can just have their employers or university recognize the skills they have. And well, I mentioned before also the idea that we think there could be use for the research sector and for edtech companies. So, well, of course, I won't spend time on that, but this is probably the starting point. We do know that there is a big amount of data, but today we have the Ministry of Education can have data on the school system. I work in a public administration, which has data as well, especially from language, French learning. And local communities can have data as families, students, so on. Most of all tech companies have as well some data, but what it's really lacking is the possibility to put them together and just to make to transform what any of us have in something which is which has a better added value. And so this slide mostly just show you the overview of our project. So we do want to create a data space and to gather all the data we could find. And the idea is to gathering also all the stakeholders that can have this data. And the vision, of course, is not just for French the countries, just to Gaia-X is an European initiative. And the idea is that all these projects are basically in line with all the European strategy for Digital Europe, digital education, GDPR, Data Governance Act as well. And the idea of creating a data space is just finally to allow data flow, create a trustworthy environment. I haven't really said a lot about this, but this is probably another key point. I mean, nowadays, some problems that data owners have is that when we want to do some projects with their data, is that they don't know how to do, because data exists, but most of the time they're not shared or not used because data owners don't know how to do that. It can be companies, it can be administrations. There is a lot of criteria in terms of well, what GDPR allows, what I'm allowed to do, what is the best interest for students and for individuals who are concerned, because of course there is a lot of personal data as well, and educational data have a particular there is sort of they're kind of particular data because they are personal, and they are also very kind of important in what a person can do. They represent what a person can do on a lifelong perspective. So well, this is probably the end, but this is kind of the timeline we have. So we are working on a position paper and we start to organize ourselves in different working groups as we said to you, and we are nowadays working all the technical guidelines, just go in depth in all the the use cases where we'll just identify where data are and what are the services that a data space could allow. Like, for example, like a data space could offer kind of catalog of all the data that are available, could provide anonymization processes, could provide micro contractualizations to allow data sharing between two companies or one company and a research lab. And well, this is exactly the point we are now. We're really thinking about what are all the services that a data space could provide other than just gathering data. And we are kind of starting as well to share our project and meet several European partners to see if we can find other countries that want to join this initiative and just go on a higher level from a European level. So the main message is we are here today just to talk very briefly about what we are doing, because we do think there can be it's an open initiative, and anyone who's interested can join us. So you have the contacts here, Claudio, my address, my email address as well, and also the addresses from the CGREF, which is kind of the CGREF today is the National Gaia-X Hub for all the sectors. So if you're interested and you want to know more, because, well, it's kind of not very easy, just to share all the information we have in such a short time. So please write to us, because well, we really would like to have more people joining the work we're doing. Well, that's all for me.
Thank you.
Thank you very much. Some people are already asking for the position paper in the chat.
Okay, it's not in line yet, because SIGGRAPH is preparing the Gaia-X web pages, but we can share the file through you if it's fine for you, and I don't know if it's open to be shared. So of course, and because it's not online yet.
Okay, do we have any other questions in the audience? Okay. So yes, please go ahead.
Yeah, it's a great goal. I commend you on it. There's so many ways that data can be used, and there's so many different kinds of learning data. You know, there's outcome data that states and nations are collecting, and as you said, the ed tech companies are creating vast amount of data. Bringing those two together seems like a big challenge, but I guess part of what I'm wondering about is, do you have a sense of like priorities with respect to what kinds of data and linkages are going to serve your stakeholders' needs most, you know, in order to prioritize in this vast space of opportunity?
I try a first response, and after I let Federica. We have some date with the call of the French bank BPI, his name is, and some call is on the sectorial data space. And we want to answer with private and public stakeholder on this call. And one of our priority is to have the element of infrastructure who can help us to develop some use case just after. We start with, I think, 3 or 4 use cases. Perhaps Federica can complete the use cases, but we want to start. But there is 3 or 4 use cases who are more more mature.
Yeah, actually, the first 2 months, we have used the first 2 months to discuss with all the people who are joining on the working group to try to make this prioritization you asked about. Like, we have just asked that any of us, anyone had to just share what their needs were and what was more important and where the most of difficulties were. And so the use cases we have identified come from there, like from skills areas. How can I use all the skills I have and skills that I have information, and how can I share, and just being in a lifelong perspective. And well, we had the voice data set. Voice data sets was also as an example. And so we have used these use cases just to go more deep and just to just analyze, well, okay, there is one need. What would you really need? What are the services you would need to use the data? If we find enough, who could be the data owner that we could put together, and that's the way we proceed. So honestly, no, it's not a universal approach at all right now. It's just starting from some examples would come from actors on the ground and just see what we can do with that. But and already we're going to have a lot of difficulties because, of course, data can come from anywhere, different ways of different descriptions of skills, and most of our work is already being, well, what are the reference framework we can use? Well, this kind of discussion, I think you can understand easily what I mean.
Thank you very much. I'm going to stop the recording. And thank you for everyone to participating.